do a teacher workshop and be like, hey.
Look at all my brilliant students, here they are.
Yeah, so if you guys could be on your best behavior, I would super appreciate it.
I don't think I look good enough here now.
What are you talking about? You look great.
You really should. Just kidding, Daddy, you're good.
Have redundancy built in.
Some people have a dress code that's not gonna be good for their Pretty sure Haley got a dress code.
Yeah.
Are you the only Haley in this class?
So Sarah, are you happy with that? Okay. So what's the difference?
Stopping you from.
Yeah, what's the difference?
But it's like easier for like guys, 'cause it's like, it's so easy to like, differentiate between like boys and girls.
Alright, put your phones away. Okay. Take out your homework that you did for today. Army, don't walk in here texting.
Army, we recorded that.
Or Snapchat.
We recorded that.
We're being recorded right now, so let's talk about the fact that we're being recorded. Sit down, be on your best behavior. Yep.
No, that's.
So, it's like interesting, or that's, yeah,
It's hard for me to like, because I usually just put it on the folder on my agenda, and I don't usually like,
Yeah, I saw my agenda.
But I had this out in class, correct? Yes, you did. Okay. Let's go over this together.
Oh wait, when's our thing?
What's name?
Or test, whatever.
Wednesday.
Yes, it's not tomorrow.
Do you have an extra one?
It'd be like a practice test.
Nope.
Oh,
It'll be a real test.
Wednesday, what is it?
Hold on a second. Anybody else need a copy of this? Is this it? No. What is everything from till now.
No, that's one. I said one. I said that.
Okay. Ahem. Sit. You have been given materials to build a voltaic cell consisting of zinc nitrate, copper, and copper 2 nitrate.
Whoa, nice.
Alright, so our first step here is to draw a picture of your voltaic cell and label several portions of it. Sarah, why don't you go up and draw a picture of it? If not, I will do it.
Oh,
I
like
handed it back to some
that.
individuals, but I'm not draw it in the.
When, what happened?
You just need to draw the picture, you don't need to label anything yet.
Yeah.
Whoa, there you go. Nicely done, Sarah.
Thanks.
Alright, my next job is to label the anode and the cathode. Army,
Get it?
I'm labeling,
label the anode and the cathode. You don't, at this point, we haven't looked up enough information to figure out which is which.
so just label which one.
So just write down the anode and the cathode. And while you're up there, why don't you tell me which directions the electrons are gonna flow?
Then back this way.
It's not the electrons that are gonna flow that way. You don't need to draw an arrow for the salt bridge, that's okay. How did you remember that the electrons go from anode to cathode?
The saying, I don't remember, but
Oh, wasn't it like?
From
nine-
anode to cathode? What is it, Isabel?
Gur.
Fat cat.
Fat cat,
cat.
fat cat.
that's
From anode to cathode.
Walk my way.
Oh, from anode. Oh, alright, Devin. Now I need to figure out which of my metals is the anode and which is the cathode. So show me how I would figure that out, Devin. The right thing right now, he's taking his reference table, his best friend.
So you have zinc, nitrate. What is it? Copper. Copper, nitrate.
Alright, before you do anything else,
Is NO3 nitrate?
NO3 is nitrate, but what's my charge on my zinc ion?
On your zinc. It's definitely +2.
It is +2, so what is zinc nitrate gonna look like? There you go. What about copper 2 nitrate? Awesome. So this is what we have. What are our half reactions gonna look like?
Cu to Cu NO3 2.
Half reactions. Do I care about the NO3 and the half reaction?
So this would be +2 electrons to get to this Cu.
Okay.
minus 2 electrons to get to this CN.
Because we have a 2 plus, he's not writing this completely correctly. Down, that was a good start.
Cool, yeah, Dev.
So, what Devin is telling us is that if we have copper, and I add 2 electrons to copper, I get copper. Something missing here?
Yeah.
Here, copper is
What's
how much?
missing, Melissa?
The 2 plus on the first one.
Alright, so if I have copper and I gain 2 electrons and I make copper solid, gain of electrons is
Oxidation. No, reduction.
Reduction.
reduction. Because we have loss of electrons, oxidation, gain of electrons is reduction. Leo the lion says grr. Okay. So here I have copper 2 plus 2 electrons yields solid copper. So let's think about what the reduction of zinc would look like.
It would be, wouldn't it yield zinc 2 plus? Oh,
Zinc 2 plus what?
2 electrons
2 electrons
equals,
yields
it's like zinc.
zinc. Well, how do I know which one of these is gonna be my anode and which is gonna be my cathode? Well, first I need to figure out which one's getting reduced and which one's gonna actually end up being oxidized. In order to do that, I need my reduction potentials. So that's where Devin's sheet, his reference sheet came out. So if I'm looking for copper 2 plus 2 electrons yields solid copper, what is my reduction potential, Devin?
0.34.
What's wrong with this number, Eli Gold?
EEV. 0.34 EV.
Naked.
It's naked,
Can't
I
have
need
that.
a unit. Can't have naked numbers, that's obscene.
V.
0.34 volts. Isabel, can you tell me what my reduction potential is for zinc?
Negative 0.76.
Is this correct?
No.
What's wrong with it, Haley?
And what?
The V. Need to put the V. Volts. Very important not to have naked numbers. Okay. So which of these has a more positive reduction potential? Sarah?
C.
Yeah, copper. So what does that tell me about copper, Natalia? Anyone want to help her out? Army? Well, is copper gonna get reduced or oxidized? Copper is going to get reduced.
So that's, and that's because, it's more popular.
So is the there's more potential for reduction?
Yeah. I'm sorry?
Is there like more potential for reduction, is that right?
Yes.
Okay.
So, I know that reduction happens at the cathode, red cat. There's a fat cat and a red cat. There's a fat cat from anode to cathode, there's a red cat, reduction happens at the cathode, and there's an ox. At the anode is oxidation. So, at my cathode, that's where reduction takes place, I'm going to have copper. And what's my solution in here gonna be, Tyler?
Copper nitrate.
Yeah, copper nitrate, And what's gonna be at my anode, Sylvia?
Zinc.
Zinc, zinc and zinc nitrate. Is zinc nitrate as itself floating around in here? An entire zinc nitrate floating around in water? It's aqueous, so what's gonna happen to zinc and nitrate when it's aqueous? It's gonna separate, it's gonna dissociate. So what I really have in here is zinc 2+ ions and some nitrate ions. Same here, copper ions and some nitrate ions. What's this? Yeah, that's my salt bridge.
Keeps that flowing.
It keeps the flow of ions such that my current can keep flowing. Otherwise, you'd have a voltmeter reading of. All right.
Wait, so you can dissociate indices? You're too close.
Yeah, it dissociates in solution because do I really care that there's nitrate in there? Not a whole lot. Does it matter that there's zinc ions in here? Okay.
Wait,
No, we have more questions.
No, I'm like, where did I leave my
Friday.
paper?
That's Saturday. No, Friday. That's really good.
All right.
Really?
Yeah, Army. Are you talking about voltaic cells?
Yeah.
Okay.
She made one.
Oh, that's awesome. Okay.
Yeah, we can make it work.
All right, so we have labeled the anode and the cathode. We've shown the direction of the flow of electrons. We've shown the salt bridge and the solutions in each beaker. Gould,
Yes.
head up there, and I need you to show the voltmeter, and I need you to,
There's such a situation here.
show
You
the
picked the one thing
voltmeter.
I don't know how to do. Voltmeter.
All you need to do is show that there is a voltmeter. Right on the, draw on the side.
They draw it on there.
I don't know where.
No.
Tell me to stop.
Hey. What? Keep going. Come on.
Where would you want to read, don't tell them, where would you want to read the voltage on that?
Right
We're
here.
gonna see. Why is it right there?
Because it's in the middle.
Because we want it to be in this wire so that we can measure,
He's right.
we can measure the flow of the electron.
Oh, either way, or no, just one way.
It's just one, they only go in one direction,
It goes
right?
this way.
From anode to cathode,
Fat cat.
through this wire.
Okay.
That cat.
Good
Nice,
work.
sit.
Good work.
Okay. Tyler, why don't you write the reaction that happens at the anode? Well, I think you have an idea. Where's the anode?
Back on the left.
It's on the left. Okay. So how do I know what reaction is happening?
Oh.
Use a paper towel.
It's like splitting apart. So like,
Yeah, let me help you out. I can give you, because that's how much a charge thing is, but enough of
back
It was close. It was a good
Alright,
try.
so we're starting with zinc. Solid. Solid zinc. What's gonna happen to that solid zinc? I don't really, it doesn't really happen like, I mean, as much as you guys love when that happens in chemistry. But something is gonna happen to that zinc, it's being oxidized. So what does oxidation mean? Look up at Leah, the line that says GER.
Oxidation is losing electrons.
Yeah, so it's gonna lose electrons. So,
Minus.
can we do a minus in a chemical equation?
It's a plus over
Yeah, plus what?
here. 2 electrons.
Yep. So I'll end up with,
Zinc nitrate. No.
what you're writing right now is called a half reaction.
Zinc.
Zinc what? I start with solid drink,
Oh,
solid zinc.
zinc 2 plus.
Yes. Nicely done.
Is that the same
Wait,
thing?
what does that say? I can read that.
Yeah.
Zinc, solid, and that's it, that's.
Well, that's solid.
I have a question.
Solid zinc yields zinc 2 plus 2 electrons.
What's the difference between that and this?
What is the difference between what I've written over here for the reduction potential and what I've written over here for the half reaction? Okay, well, this one you're starting with the solid, this one you're ending with the solid, but why did I write it like this over here? Why would have this been wrong?
Oh, you can't. I don't know. Is that when you started off with zinc?
That was losing, or that was gaining electrons.
That one's gaining electrons, which means it would be
Reduction.
reduction. Is reduction happening at the anode? No, reduction happens at the cathode. At the anode, we have oxidation, anox. So we can't show reduction. We can't show the gaining of electrons. We need to show the loss of electrons. So here we're showing a loss of electrons, which is what Tyler told us. He said we're gonna lose electrons, but I'm not gonna put a minus sign here, I'm just gonna add it to the other side. Make sense? All right.
I go have some, get some water.
You're like, Alice, why don't you write the equation that happens at the cathode?
Is that some,
Will you tell me?
So those are just back. So.
Was oxidation and reduction.
I was talking about of course.
Well, in this cell, oxidation is gonna happen at the end. The reduction isn't happening with zinc. Oh, hold on a second. What's up, Haley? Okay. Go ahead. We'll go back to you. You can write it near the cathode, that's okay.
So even though that's reduction of zinc over there, because it has a lower potential, it's gonna be oxidized instead.
I want you to wait up here. Is this showing a gain of electrons or a loss of electrons, Melissa? A loss, yep. So, loss of electrons is oxidation, but what's happening at the cathode? Red cat? Reduction's happening at the cathode. So I'm not gonna write my oxidation reaction, I'm gonna write a reduction reaction. What is the reduction reaction look like? Well, I can tell you, if we look over here, we're thinking about reduction. We know that reduction is a gain of electrons. So what could I write it to look like that would make it look like it's, oh, hey, Yeah. Gain of electrons, show my copper gaining electrons.
So on the test or quiz, whatever you want to call it, we're just gonna, we'll get a question like this and we'll just.
Yeah, that's a safe bet.
So in like the, when you find reduction potentials, is the one that's getting reduced, you just keep it like that for the half equation? Keep it like that,
Yes.
okay.
Alright, so that was number 3. Nice job, Eli. Number 4. Skip number 4. Oh. For number 4, write down what is the voltage in this cell. What's my voltmeter gonna read? Marcus,
1.
come up here and show how that problem is.
Zero. I think the other answer is right.
Alright, Haley, talk him through it.
What?
He wants to find the voltage of this cell. How is he gonna do it? You don't know?
Oh, I have an idea.
Tyler has an idea.
Do you just like add the voltages?
Well, I add the reduction potential. I can add the voltages at the anode and the cathode. So what's my voltage at the cathode?
0.34,
Correct. What is my voltage at the anode?
-0.76.
So you just do that.
Well, that would be if reduction was happening with my zinc, but
Positive 0.76.
yep, I gotta make it a positive because when I switch the direction of that equation to make it oxidation, I also needed to switch the sign. So, do the problem out, write it out. For those of us taking notes here.
Yeah.
What is your?
I see it part of it.
So close, Michael.
With the,
One.
Oh, okay, so we have to know.
Oh, monkeys, monkeys.
Marcus, write my name next to it.
there you go. Alright, put a box around it. I would like to make note that 0.34 nothings and 0.76 nothings don't make up 10 volts. And 0.34 volts, 76 volts. Okay. Track of your units. Army, look live.
We're in chemistry.
Posture.
Wow.
Posture.
Wait, so it's like 20, 30.
Questions about how that worked?
Why did we make, .76 positive here?
Can someone explain that to Sarah?
Because
Devin, why don't you take this one?
start off, when you do a reduction over here, it's -0.6, -0.76. But when it becomes the anoid, it's no longer reduction, it's like oxidation, so you have to flip it.
The information that I'm given right here is a reduction potential.
It's so much sense.
But I have an anode and a cathode, so I want reduction potential for the cathode, and I want the oxidation potential for the anode. Fortunately, we don't have a table of oxidation potentials. But fortunately, because we have a table of reduction potentials and oxidation, we just need to switch the sign for the reduction potential. All I needed to do was take my reduction potential and then make it positive to make it oxidation. So when I flipped the direction of this reaction, when I flipped the direction and went like this, I also flipped the sign of the voltage.
And is that the anode or the?
This is at the anode. happens to the mass of the zinc electrode as time passes? Think about it, and then I will call on one of you, unsuspecting creatures. Kenley. So the zinc electrode's gonna get bigger. Why do you say that?
Because, the zinc nitrates, like dissociating, or
What looks like it's happening here, if you look at my half reaction, I got solid zinc, so that's what's in the electrode right here. And what's happening is, it's losing its 2 electrons, they're gonna go through this wire to get to the copper. And what's actually happening is I'm left with a zinc 2+, which floats around in solution with the nitrate ions.
so it's getting smaller.
Yeah, so this zinc electrode is gonna get smaller. If you said, hey, can I borrow your zinc electrode for an experiment from me? And I was like, okay, but don't lose any zinc. And I took the mass of it beforehand, and you went and built this cell, and then when you were done, you brought back the zinc electrode, and I weighed it again and put it on the balance again. There would be less zinc. So would I be mad?
It'd be kind of annoying.
Oh, I'd be so mad.
Can you
But
not
you
get
get
it
over
back?
it because you look kind of.
Yeah,
Can't you just-
well, if she showed
Can't
me,
you
I made
do
this.
the other, can't you
So-
make some kind of thing where zinc is the cathode?
You could. If you didn't use copper, you could have found something else where zinc was the cathode. Let's find one. Let's take out our table of reduction potentials. If someone can find one, someone can find me an example.
Sodium,
Sodium, how do you know sodium?
because the reduction potential is negative 2.71.
So negative 2.71 is less positive than zinc?
Yeah, which is negative 0.76, so zinc has a more potential reduction.
Yeah.
Yeah.
Which would make it the cathode. because
So-
we're at
Exactly, so Kelly would have to go use sodium. And then,
cathode, or anything else.
okay, and then she wouldn't lose any zinc.
No, it should be making zinc. But what the point of that to be even?
Think about this though. At my cathode, what's gonna happen to the mass of my copper
Wait, where's the?
electrode?
Oh, it's gonna get.
What's gonna happen to the mass of my copper electrode? Helicase.
Increase,
It's gonna increase, why?
because it's gaining,
Yeah.
yeah.
I've got copper 2+ in solution, and when it gains electrons, it becomes solid copper. So here, I'm gonna make more copper. So if Kenley went and wanted to do this thing with the zinc to trick me about what she was doing with her zinc electrode, so she made that the cathode, and then I went and I took a measurement of the zinc, I took the mass of the zinc after. This is the one where zinc is the cathode and sodium is my anode. What would have happened to the mass of the zinc, Kelly Stewart? What?
Can you repeat that?
If Kenley made a voltaic cell where she had sodium as her anode and zinc as her cathode, and she borrowed some zinc from me, and I took the mass of it before I gave it to her, what would happen to the mass when I got it back? What happens to the mass of the well, here what's happening is I'm gaining electrons to become solid. So it would, if I get more solid, it would increase. Good. So then I would be like, whoa, Kenley, you made more zinc.
Yes. Why would she want to buy, like, I think be more like a favor also. I'm gonna make you some more things, this experiment.
Well,
So like, the point of this is.
Kenley is a very thoughtful person.
But like,
She really enjoys doing chemistry in her free time.
so the point of this would be just to make more solid, more whatever, more of whatever the cathode.
Well, the point is, what the real point is to create a flow of electrons because
Oh,
once
for
we,
energy.
right.
Yeah.
So the real point is to create a flow of electrons. Getting more copper out of it is just a side effect.
I'm confused in case you want
So
to.
if
Alright,
there's
hold on. Haley and then Kenley.
So if there's more electrons, it will increase?
If it gains electrons, it'll go from being an aqueous copper 2 plus to a solid copper.
Can we do another?
Oh, we are going to, once we finish this.
So did you copper 2 plus is from the liquid?
Right, copper 2 plus is in solution, remember it comes from the copper nitrate. So when electrons come over to this side, it says, hey, there's some copper 2 plus here, I'm gonna go join it, and then it becomes copper solid and it grabs onto this solid copper that's already there.
What about if it loses electrons?
If it loses electrons, like with zinc, the electrons go away from zinc through here, through this wire, and then solid zinc loses electrons, so I'm left with zinc 2 plus, which floats around in solution.
So it becomes solid state.
Yes, so what happens to the mass of the zinc? It what? Decreases, but what happens to the mass of the copper? It increases. That's pretty cool, right?
Could you like get it to the point where you just have nitrate and the copper? Like, would you, that way, like, you run out?
In theory, I've never gotten to that point.
So if this isn't like a purification method by any means,
No, what you're really using this for
is to create energy.
is to create that flow of electrons.
That's why it's a battery.
Yeah, that's why Breaking Bad, when Walt and Jesse are out of battery and they're just stranded with their RV in the desert, that's how they're able to use ingredients in the lab to start their car.
How big do they have to be?
Actually a lot bigger than that.
They're like how, like
I
this?
I don't know.
Wait, what?
I don't know. All I can tell you is this, if you had set this up in the lab with a beaker and a beaker, some wire, I can tell you that's not enough to, not nearly enough to start a car.
You could
What Walt actually sets up is a little different, but the concept is.
Is it more powerful?
So powerful.
Like, could it
are there more
theoretically,
involved?
it was,
Theoretically, I don't know,
Like, is there a
I think the
possibility?
science of that episode was a little iffy, but is it possible? In theory.
yeah, okay. Let's say, what was your question?
So Kelly, your question's answered?
How long?
Sylvia, was your question answered?
Yeah.
Okay.
How are you doing so nasty?
I'm sorry?
How are you doing?
I'm happy to be teaching you.
Wait.
Okay, so let's say a copper 2 nitrate solution is blue in color. And that's actually true. Copper 2 nitrate is blue. I'm sorry?
We were talking about something else, but it had something to do with.
Anyways, it's blue, and it's actually a very beautiful solution. I don't know if you guys remember it from when we did the solutions lab back in the fall. It's quite beautiful. Is it like this? No. It depends how concentrated it is. So, if it's blue, what's gonna happen to the color of the solution as that cell operates? Think about it and raise your hand once you get it.
As this.
Wait, do we know what the other
Wait,
color
what's
is?
blue?
This here, copper
The
2
anode?
nitrate. The solution, copper 2 nitrate at the cathode is blue. The solution is blue, even though we all know copper is not.
Is copper 2 plus or the anode theory making it blue?
The copper 2. Keep it, think about it. Raise your hand when you think you got it. Alright, 2, 3, 4, 5 people get it. 6, 7, Army, sit up. 8. Alright, Isabel, what's gonna happen? What? What would,
Increase.
it would what?
Increase.
You think that blue would increase, does anyone agree? Does anyone disagree? Alright, Melissa, why would the blue, why do you think the blue wouldn't increase?
The electrons in copper are turning solid, and so it's lessening the copper in the solution.
Yes, so here, Isabel,
Yeah, I just wrote down today.
that's okay, so we're starting with copper 2 plus, and when we add electrons, we make solid copper, which means we get less copper 2 plus in the solution, which would make it a lighter solution.
Yeah.
However, if I chose a different metal on this side and this was the anode, then it would get darker because you'd end up with more copper 2 plus.
So really, it could be flip-flop, if everything was like backwards.
If I got a different metal, I could flip flop it.
So really,
That's why every time you do this, you're gonna have to look at the reduction potentials and figure out which is the anode and which is the cathode. Because just because the copper is a cathode this time, if I found something with a more positive reduction potential and paired it with the copper, that would then be the cathode and this would be my anode.
that makes sense, okay.
Okay. What does a salt bridge do? Army? Why don't you just tell me again?
Like, keeps the flow ion, so the voltmeter isn't zero.
Exactly. Oh, so what would be the reading on the voltmeter if you remove the salt bridge, everyone?
0.
Zero. Sylvia, you're so quiet today. What would it be?
0.
Zero, there you go. All right, questions about this whole thing? Can I erase what's on the board?
Wait, so that's what the,
Can Eli erase what's on the board?
I think it's just.
Asking me or?
Yeah, you're a super eraser.
Oh. So is the voltmeter on like the salt bridge or the wire?
The voltmeter's on the wire.
I'm sure I had to know which side it's on. There you go.
We actually, we only have 2 minutes left, so I'm just gonna talk about, these problems. So these are what you need to expect to be doing for the problems. I will get you some worksheets with extra problems, but they're all done with the same method. So I'll give you some worksheets for that. I will post them on the portal. Your job between today and tomorrow is to come up with questions. So questions you want to ask before we do the test, which will be on Wednesday.
Yeah, I just
I
need
can post something
stuff.
like that on the portal.
Yeah, I need stuff.
Do you need to talk? No, it's.
Oh,
You
man.
can reschedule. No, I don't have it. You wanna take it? No, because that's the last day I can. class on Friday, so I need to do
I'll
a
check
little
that for you.
bit.
Probably this in a week.
I have a question. What
What specifically is gonna be on the test?
I did two
Acids
projects.
and bases,
So you
and
were
then the weak
acids,
acids,
chemistry.
and then,
Alternate. All my
and then
projects are finding
electrochemistry,
that
so a cell.
I do for long.
And tomorrow we will review. Yep. You can, if you go home and start having total freak out, let me know and we'll do another one. I don't want, my goal is not to stress.
Yeah, I mean, like, to me, it's not like, it would be more helpful. I would rather do it like Tuesday,
You wanna do it tomorrow?
I don't know, I have to like see it, cause I'm.
Send me an email. If I don't hear from you, we'll do it on Wednesday. If I do hear from you tonight, we'll figure out another time. Okay? Does that help at all?
Yeah, I'm excited.
So you